Hello everyone, welcome to Mind is Fun Education. In this video, we will be learning a new way of representing the distribution function, and then the new way what we are going to call is a cumulative distribution function. So far we were learning probability mass function in case of the discrete, probability density function in case of the continuous random variable. Now we will have the tool, and that tool is a unified tool that will not distinguish between discrete case or the continuous case. We can represent the distribution either it is from the discrete or continuous or maybe mixed using one function, and that function that we are going to call is a cumulative distribution function. So the beauty of the cumulative distribution function is that it works for any kind of random variable, whether discrete, continuous or even mixed. So now instead of thinking in terms of the PMF or PDF separately, we will have one function that tells us everything about the distribution of random variable. This is what the definition of the cumulative distribution function, or in short CDF. What is it? It is probability that random variable x takes the value less than equals to little x, and this probability we are going to denote with this notation. So whenever we will be using this capital F and this subscript x, so this capital X will tell you that we are talking about the cumulative distribution function. In other books or in other places you will find that they will be using some other letter, but in our lecture we will be using capital F to denote the cumulative distribution function, and this subscript will tell you that what random variable you are talking about, and this little x is a argument of this function, right? And the cumulative distribution function is nothing but it is just finding the probability that random variable takes the value less than equals to little x, right? So you are finding the probability that random variable takes the value little x. Overall, what you are doing, so let me first of all talk in case of the continuous random variable. If you have to find this probability, how would you do that? With the help of what you will do, so you will simply find the integration from minus infinity to what point you are finding the probability x, so you will integrate over minus infinity to x, and the PDF, probability density function. So what you are doing, you are finding the probability till point x, or let's take an example of a simple random variable. Let's take the uniform random variable. So we have the PDF of this uniform random variable, and that have some height from a to b from in this interval, and that height will be 1 divided by b minus a, and this is a probability density function for a random variable x, right? So let's say this x belongs to somewhere here, right? So what you are doing, you are finding the area from minus infinity to till this point, right? And it will be 0. Let's say x belongs to somewhere here, right? Then again using this you are finding the probability till this point, so you will integrate from minus infinity to till this point. So here you will get some area, right? Let's say x belongs to somewhere here, right? In this case, you will integrating from minus infinity to till this point, that is x. So till here, this region you will have the 0, but this region you will have more area than the previous when x was at this point. Let's say if you take the x here, then the probability will be this area. Overall point is that you can think of this cumulative distribution function as a accumulator. It gives you the accumulated probability till the point x, and x could be maybe here or maybe till here or maybe till here, right? So if you have to draw the CDF plot of this CDF for this uniform random variable, how do you do that? You must have some kind of sense that what it will look like, right? Let's say the x is still here, right? So you will integrating from minus infinity to here. The area under this is 0, right? So you will have nothing till this point, right? And as you increase the value of x, let's say if you fix this x till here, you will have some probabilities, right? If you increase the x, you will the probabilities will more accumulated, right? So from here the probability will increase linearly, right? And once you are at this point, you have accumulated all the probabilities. All the probabilities means you have accumulated till all the probability is 1, right? So after that it will be 1. So the CDF in this case is a linear, and then it has the maximum till 1, and the maximum should be 1. Why? Because these CDFs are nothing but the probabilities, right? And probability, from the basic exams we know that probability can never be less than equal, probability can never be greater than 1, it will be always less than equals to 1. So the maximum value of this CDF or any CDF will be 1, right? And one point to note here, these CDF will always be increasing. It will never happen that it is increasing, then decreasing, and then increasing. It will never happen. Why? You have also seen from here, right? So let's say x is here, right? So you are integrating from minus infinity to till this point, and you have the 0 probabilities. And as you go further right, the accumulation of probabilities will always increase. Let's say if you are till here, then the total probability will be this much of area. As you further go on right, the accumulation or the area will increase, right? It will never happen that if you are going right towards right, that the probabilities will be first increasing and then decreasing. It will never happen. Even you can see from this particular example, right? The probabilities will always increase because the overall area will always increase as you go to the right. So x may be, this x could be here or maybe here or maybe here or maybe here. As you go towards right, the accumulation of probabilities will always increase. That is why the CDF will be non-decreasing function. It will be always increasing function, right? And one question you would have in your mind, that why this one is linear, right? So you can easily check it mathematically. So what we are doing, we are integrating from minus infinity to any point till x. So this x could be anywhere, right? And we have this PDF, and it will be from a to b, right? So instead of taking the integral from minus infinity, we can take from a to till any general point x, and till there we have the height of this PDF, or the PDF is 1 divided by b minus a dt, right? And we can simply integrate this will be 1 divided by b minus a x minus a, right? So the equation of this line is 1 divided by b minus a x minus a. And once we have integrated or occupied all the probabilities, that means it will be 1, so maximum it can go to 1, right? And one more point to note here, once we have the CDF, we can find the probabilities of any interval. Let's say if you want to find the, let's say you have given the CDF. If you have given the CDF, that means you would have given this function, that probability that x is less than equals to little x. This one is given to you, right? And you have been asked that find the probability that random variable x takes the value greater than equals to 3 and less than equals to 4. You have the CDF, you can easily find the probability of any general interval. How you can do that? So you can find this probability. So once you have this function, that means you know that what will be the probability that random variable x or the little x is 3. That means you know this part, probability of this part, and you also know that what's the probability that random variable x will take the value less than equals to 4. That means you know also this part as well. And from the additivity, we can write this probability that random variable takes the value less than equals to 4. We can write this as a 2 part using the additivity. How? So this part till this part plus this part. So probability that random variable takes the value less than equals to 3. So we have considered this part. Now we need to consider this part. So plus, using the additivity, we can write that probability that random variable takes the value greater than 3 and less than 4. If we have this cumulative distribution function, we know this and we also know this, so we can find this probability of any general interval. We will take example, then you will have much clarity. The point here to note is that if you have probabilities, if you have the cumulative distribution function, then without finding the PDFs or the probability density function or PMF, we can directly find the probabilities of any general interval. And if we have the CDF, we have also the PDF. So right now we are talking about the continuous random variable. So if we have the CDF, we have the PDF. How? So how do you find if you have this CDF? That means you have the integration of the PDF. What you will do? You will simply, if you want to find the PDF, you can simply take the derivative both sides with respect to x, and that will give you the probability density function. So if you take the derivative with respect to x in both sides, So you know from the basic calculus that if you take the derivative with respect to x, right, and we are integrating from minus infinity to till this point x, and if you take the derivative of this integration, then it will be nothing but this integrand itself, right? So from here you can find the PDF. So once you have the cumulative distribution function, you can easily find the PDF by differentiating both sides, right? And this is very important. The same thing we can do for the discrete case. So what we have done is this for the continuous random variable. And there is one more point to note, is that here the PDF is a function of this small t, right? And why we haven't write here small x? Because this small x we have reserved for the argument of the cumulative distribution function, right? And these are somehow related but different. You can see the plot of this CDF, and this is the plot of the PDF, right? So we cannot use the same argument for both the cases. So here I should write it as a argument or the function of this small t, right? So this small x is saying you that up to what point you are accumulating the probability, right? I hope it is clear that why we are not using this small x and why we have used the dummy variable, that is the small t. Now let's move and look at the cumulative distribution function in case of the discrete random variable. Now again, in the discrete case, the definition of the cumulative distribution function will remain same. It is nothing but just the probabilities such that random variable or probability of random variable x taking the value less than equals to little x. Earlier we have used the integration. Now in this case we will have the summation, and if you have to find this probability, how would you do that? So you will integrate over all the probabilities where random variable x takes the value less than little x, right? So this will be equal to summation, and again I am using a dummy variable or argument for this PMF, that is k, right? And if you have to find all the probabilities, what you will do? You will sum over all the possible values of k, right? But since we are writing it for the CDF and this CDF is the argument or the function of this little x, so depending upon this little x you will integrate or you will sum the probabilities till x, right? So instead of summing over all possible values of x, you are going to sum or run this summation over the value depending on x. So you are going to sum over these k depending on the x, right? So that is why this k will be less than equals to this x. I will take an example, you will have the clarity, but you should have the clarity at this point, right? If you have to, if I will ask you, if you have this PDF or the PMF, and if I tell you that give me the sum of the all probabilities, what you will do? You will sum over the all possible values of x, or the over the all possible values of this random variable x that it can take, that is the little k, right? So the summation will go over all possible values of this little k, right? And this will give you the summation 1, right? But you are not going to sum over all possible values of k. For this cumulative distribution function, as per the definition, you are going to sum the probabilities till x, right? So this sum will not, you will be not summing over all possible value of k, instead you will be summing this till x, so less than equals to x. So that is why here this will be, the summation will over k less than equals to x. I hope this is very much clear to you. Let's take an example of a discrete case. Let's say if we have this PMF, and let's look at the plot of the CDF. So this is the PDF, and we just want to have a look at what will be the plot of this given PMF. Sorry, I told you the PDF, but this is PMF since we are talking in case of the discrete case. And again, you see that we have used this dummy variable k. Why? Because if you will use again x, you will have the confusion, and moreover we have already used this for the CDF. That is why we are not using again for the PDF, right? And so we have used some another argument or the variable that we are calling it as a small k, right? All right. And the CDF will be the, obviously it will be the function of this small x, right? And on the y-axis we will have this CDF. So what we do, the point is to, we need to accumulate the probabilities depending upon the values of x. So might be x could be somewhere around here, right? So we will be summing over all the probabilities till here, till at this point, right? So you will get no probabilities, so we will have 0 till this point, right? And let's say the x is some around here, right? Then what you will do, you will sum over all the probabilities till x. So you will get this 1 divided by 4. So from this point, that is x is equals to 1, you will have a jump of 1 divided by 4, right? And again, if you increase the x, the sum of the probabilities till this point will be 1 divided by 4. So till this point you will have 1 divided by 4, right? Because till this point you are accumulating how much probabilities? 1 divided by 4, right? And once you pass this point, that is 3, you will accumulate more probabilities. Now it will be 1 divided by 4 plus 1 divided by 3, that will be 3 divided by 4. So there would be a jump here. And how much this jump will be? So this jump will be 1 divided by 2. And how much probability so far you have accumulated? So you have accumulated at this point 3 divided by 4. Till this point you have accumulated 1 divided by 4, right? And once you go to the right, you will be accumulating more probabilities. So till 4, you will be accumulating this much of probabilities, and once you pass this x is equal 4, then there would be addition of this probability as well. So overall, now you will be accumulating 3 divided by 4 plus 1 divided by 4, that is 1. Right? So this is how the CDF will look like for this given PDF. Again, the point to observe, the CDF is non-decreasing, that is always increasing. So you will have the constant value, but it will never decrease, it will always increase. So till here you have the fixed value, then it is increasing, and again it is increasing. So it will never happen that the CDF you will found that it is increasing, then as you go on then it will decrease. It will never happen. Right? So I hope it is clear that the definition of the cumulative distribution function in case of the discrete random variable. And in case of discrete random variable, you will always have this kind of staircase function of this cumulative distribution function. There is one more point that I will tell you that might be confusion for you, that if I ask you what will be the CDF at x is equals to 3. So at x equals to 3 we have two values, this one and this one. Which one we will be using? As per the definition of CDF, we are summing over all the possible values of random variable x that is less than equals to x. So we are considering till this point because we have this equality, right? So if I ask that what will be the what will be this value that at x is equals to 3, that means what we are asking is the probability that random variable x takes the value less than equals to 3. So we are considering this 3 as well, right? And we have at the 3 the hike that is giving you the half probability, right? So the accumulation of probability will be till x is equals to 3. So we will be considering this point, this value, right? So at the CDF value at x is equals to 3, little x is equals to 3 will be 3 divided by 4, right? We will be using this. I hope it is clear. Why? Because of the definition, and the definition we are including this equality sign. So we need to include the probability till x is equals to 3 if we have been asked for to calculate this. I hope this is clear. Let's now summarize all the properties we have seen so far while discussing the CDF. So as per the definition, if we have this CDF, what does it mean? It means that we are finding the probability of random variable x that is less than equals to x. So what we are doing, we are finding the probabilities till the value little x, right? And we have also seen that it is the CDF is non-decreasing. What does it mean? Non-decreasing. It means that, let's say if you are taking any value till y, this is y, and if you are taking a value till x, or you are finding the probability till x and till y, right? And this y is greater than or might be it will be equals to x. In this case it is greater, right? So we are considering a general case. So what the CDF is non-decreasing, that means whatever the value you will get corresponding to this, and whatever the value you will get corresponding to this, so this value will be always greater than equals to this value, right? Because if this x is less than y, so you are accumulating the probabilities till at this point, and if y is greater than this x, that means you are accumulating the probabilities till this point. So obviously this will be greater than this value, right? And also if you are saying that it is non-decreasing, so if you are taking any point y that is greater than x, right, then their CDF, if those are non-decreasing, the accumulation of probabilities till this point will be greater than till this point, right? So what we are saying is that if y is greater than equals to x, that implies that the CDF will be also greater than, right? Because if y is greater than x, that means till this point we are accumulating more probabilities than this point, or maybe equal. I hope this point is clear to you. Now the value of the CDF will tend to 1 as x tends to infinity, right? You can consider this example of CDF, or maybe this example, as you go to the right or to the infinity, you will be accumulating probabilities, and at the time you will be accumulated all the probabilities, right? If you go, so it will converge to the value, the maximum values that the CDF can have is 1. We have already seen that. And one more point, that the CDF will tend to 0 as x tends to minus infinity, right? What does it mean? It means that if you go to the leftmost point, right, maybe there will be no probabilities to the vicinity of minus infinity, so you will be accumulating none of the probabilities, right? So that is why this will tend to 0. So the value of the CDF will belong somewhere between 0 and 1. And if you have to write this same thing in the CDF notation, how you can write? You can write like this. So at x is equals to infinity, this is nothing but we are finding the probability that random variable x takes the value less than equals to infinity, and that will be, and that will be 1, right? Because, and this you can write in terms of the CDF notation. So this probability will be 1 and this will be 0. And we have also seen that we can find the, if we have the CDF, we can find the probability of any general interval. Here what we have seen, right? So let me generalize this. So let's say if you want to find the probability of this interval, that random variable takes the value x1 and less than equals to x2, right? So this can be written as, if you want to find, and if you have this already info about the CDF, then how you can do that? So this would be nothing but the probability that random variable x takes the value less than equals to x2 minus probability that random variable x takes the value less than equals to x1. How we have done that? Using the additivity, and I have taken this as an example. So you can find this probability, right? You can just simply bring this to left hand side, and this is what we have written it. And if you have to write this as in terms of the CDF notation, so this will be x less than equals to x2 in terms of the CDF notation. This is nothing but the CDF value or the CDF of at x2 minus the CDF at x1. So if you have given the CDF, you can find the probability of any general interval. You can consider this as property, but this is the, you can see as a usefulness of the CDF, right? Okay, that is all in this video. Next video we will look at one more important continuous random variable, that is the normal distribution. Thank you so much.